Hello everyone, welcome to my YouTube channel. This is Filipino explaining. In this video we are going to look at irrationality proofs, and we have here a problem. Prove that the square root of 2 is irrational. Prove that the square root of 2 is irrational. First, before we prove, we want to look at some of the things that we have to know first. We will prove this result using the following fact, that any rational number x can be written in the form x is equals to p over q, where p belongs to z, q belongs to n, and q is not equals to 0, and at least one of p and q is odd. We will also use this result that let n be an integer, then n squared is even if and only if n is even. Remember, there's a video I have created on this result 2, this property 2, that says let n be an integer, then n squared is even if and only if n is even. If you haven't watched that video, please watch, make sure you watch. So let's prove of irrationality of root 2, or the square root of 2. We argue, we shall use contradiction. We can just write we argue by contradiction, and suppose that the statement is false, i.e. that root 2 is not irrational, then root 2 is rational by the definition of rational numbers. rational numbers. This means that square root of 2 can be written as the square root of 2 is equals to p over q, where p and q are integers, with q is not equals to 0. By, say this is 2 2, or this 1 this 2. By this result, I think 1 star, yes, 2 stars. So by this result, we can further assume that at least one of p and q is odd. Squaring each side of root 2 is equals to p over q, and clearing the denominators, we are squaring both sides, and in clear the denominators, we get 2 is equals to p over q squared. Q is equals to p squared over q squared. If you multiply both sides by q squared to q squared to clear the denominators, remember the denominator is q squared, so we get 2q squared is equals to p squared. Thus p squared is 2 times an integer and hence must be even by the definition of an even integer. By and 2 stars this result, now by this result, by this result, it follows that p must be even as well. Hence p is equals to 2k for some k that belongs to z by the definition of an even integer. Substituting this into this p is equals to 2k into this, we get 2q squared, where there is p, we replace p with 2k squared, so that we have q squared is equal to 2k squared. Are we there? Because if you square this, it will be 4. This is 4k squared, so that you divide by 2 will remain with q squared, which is equal to 2k squared, because here divided by 2 will remain with 2. Are we there? Thus q squared is 2 times an integer, and hence must be even by the definition of an even integer, and therefore both p and q must be even. This is a contradiction to this. This is a contradiction to our first result here. This is a contradiction to this irrational number x can be written in the form that. This is a contradiction to that. Hence, our assumption that the root of 2, the square root of 2 is rational, the square root of 2 is rational, was false. Now was false. Therefore, root 2 must be irrational. Therefore, root 2 must be irrational. And up to that point, we have proved. So you can see from the beginning as it flows to that point. Thank you so much for watching. Till next time.